Evaluate each expression. All right, so we have this statement, the log of 36 base 9 minus the log of 4 base 9. Basically, we have a difference of two logs that have the same base. Then we're dealing with this rule here in the second one in our list here, which says that the log of a minus the log of b can be rewritten as the log of a divided by b. Here your a and b are 36 and 4. The first number goes on top of your division, so when we rewrite it, we're going to write it with one log base 9, and then we're going to write 36 on top of the fraction and 4 on the bottom. You have now expressed a difference as division, and so you're set. And then from there, that's going to be what? Log 36 divided by 4, of course you know, is 9, and then we'll have base 9 again, and now you're dealing with this rule here, right? That rule that says log of b base b is equal to 1. So whenever these two things match up, whenever whatever you're taking the log of is the same as your base for the logarithm, the answer is just 1. And the reason why that is because you're basically saying, what power do I need to raise 9 to get 9 as an answer? Well, the power is just 1, right? So our answer for A is just 1. All right, let's look at B. B is a little bit deceptive. Be careful. Don't look at this product and then jump to that first rule in our list and say, oh, it's a product, therefore I can write it as a sum. That isn't correct, actually. You notice in that product statement that we have in the list of properties, we're taking the log of two things that are multiplied and saying that that can be written as a sum, right? That's not the same thing as what we have here, right? Here we have two logs, not one log, right? And the logs are being multiplied. So it's not the log of a product, it's the product of logs, right? So it's not one log, there's two logs, and their logs are being multiplied instead of having something like this where we'd have something like log of 5x, right? That's the log of a product. That's different from, say, log of 5 times the log of x, right? This is the product of logs. They are not the same thing. Okay, so then the question you might ask is, what is the rule then that we should use here? Well, the rule that we should use here is actually the third one, which is a little bit strange or peculiar, but that one will work. It's actually the rule that says that an exponent can be written as a factor or a product, right? So what we mean by that is we can actually treat this like an exponent. For example, if it had been 2 times the log of a, we could write the 2 here as an exponent and say it's the log of a squared. That we can do. So we can bring this whole thing that's out in front up here as the exponent of 49. So let's do that. We're going to write it as log of 49 base 2 with an exponent of log 2 base 7. So very strange to have that complicated exponent, but that's the way it is. Not too bad. All right, from there we might want to write that log of 49 as log of 7 squared base 2. And then remember, it already had an exponent of log 2 base 7. Now, this can multiply that, so we'd end up saying that it's log of 7 base 2 with an exponent of 2 log 2 base 7. Okay, so again, complicated exponent, but there it is. And then from there, this exponent can be distributed up here as an exponent of that because it's a number out in front of the log, and we can again write all those products as exponent if we want to. So we can end up saying log of 7 base 2, and now we'll have log of 2 to the second power base 7. All right, so this is all getting a little bit complicated, but we're almost done, I promise. This 2 to the 2 can be evaluated, right? So we can certainly say log of 7 base 2, and then so we've rewritten all of that, and then we'd have as an exponent log of 2 squared, which is 4 base 7. Okay, almost done, I promise. Now from here, we're in pretty good shape because we can say that all of this here, the 7 log 7 can cancel out and end up producing the answer log of 4 base 2. And the reason why we're able to do that here is because we have this rule here. This rule that says whenever you have this base to the power of log a base b, all of that can cancel out, just leaving you the exponent, right? So that's what we had here. 7 to the log base 7 power has to cancel out to just produce the answer 4. And then we're saying log of 4 base 2, and this can be evaluated pretty easily. We can say, what do you raise 2 to get 4? What power? And the answer, of course, is 2. Or you could have even kept it as the log of 2 squared base 2, and remember that this 2 comes out in front, right? Saying that it's 2 times the log of 2 base 2, and then remember log of 2 base 2 is really just 1, so it ends up being 2 times 1 or 2. Same answer we got before. Okay, from there let's do example C now. One thing you don't want to do is kind of do this, right? Cancel out these using this property over here on the right. Can't do that here because we actually have a more complicated exponent than that. All of this is the exponent, so we need to rewrite that first before we try to apply any rule like the one I just mentioned. And luckily we have what? A sum, which can be written as a product according to the property over here. Okay, so let's rewrite that as a product. So we'll have that exponent become log of 11 times 7, right? So we're writing a sum as a product, so we need to multiply those two items. So 11 times 7 is 77, and the base remains 4. Now at that point, we can apply this property over here. So the 4 log 4 cancels out, just producing an answer of 77. All right, our final one that we have to work out is this problem here. The one that has e log of 27 base e cubed. So the base of this log is actually e cubed. That's the base of the logarithm. It's e cubed. And we have e to that power. So in order to work this one out, we're going to have to rely on the change of base formula. This is another difficult problem. So this change of base formula has to be used. Let's just talk about the exponent here, just this exponent piece. Log of 27 base e cubed. Then you can rewrite that as, so we're just rewriting the exponent here. You can rewrite that as log of 27 divided by log of e cubed. You can do that if you want. That's a change of base formula, and we know the formula tells us that those two things are equivalent, right? All right, so we're allowed to do that if we want. However, that's not going to be particularly helpful if we just do that. So what I want to do instead is I want to use a special form of log. We can use any log we want. We could use log base 4, log base 5, right? Here I've written it as log base 10 generically. But that doesn't do us any good. What we want to do instead is to actually rewrite this using ln. Let's use ln 27 divided by ln e to the third power. I'm allowed to do that because I can use any base log I want. And so in this case, log base e is the same as ln. I'm allowed to use that. And the reason why I want to use that is because I know that ln and e will have this effect that the ln of e is just 1. So what I can do here is rewrite this and say, well, that's ln of 27, right? And then ln of e, I can bring this 3 out in front as the coefficient here. So it'll be 3 times ln of e. And then the ln of e will cancel out because remember, ln of e is just log e base e, right? So whenever this happens, we get 1. So finally, we will have ln of 27 over 3, right? Because remember, this canceled out or became just 1 or 3 times 1. All right, great. So remember, all that was the exponent. I was just messing around with the exponent, and that's what the exponent becomes. Now, from there, I want to rewrite that one more little bit. I can rewrite this to say that this is 1/3 ln of 27, right? 1/3 ln 27, because this 3 on the bottom is the same as multiplying by 1/3 because we're dividing by 3 and those things are equivalent. And then remember, I'm allowed to take any coefficient in front of the log and bring it up as an exponent. So finally, this would end up becoming ln of 27 to the 1/3 power. Now you may say, geez, what was the point of all that? Well, come back here. Remember, that's just our exponent, right? So come back here. We have the base e that we had here. And we're going to put this new exponent that we just evaluated, which was ln of 27 to the 1/3 power. Do I know 27 to the 1/3 power? I think I do, because remember, an exponent like that is just the same as a radical, right? With an index, in this case, of 3. So it'd be e ln of the third root of 27. So remember, the third root is the same as the rational exponent 1/3, right? So if that's the case, then I'm able to say that this is e ln, what's the third root of 27? In other words, what number times itself gives you 27 if you multiply that number by itself 3 times? Well, it'd be 3, right? Because 3 times 3 is 9, times 3 more is 27. So the third root of 27 is just 3. And then finally, remember what ln is. ln is really log base e. So this ln of 3 is really log of 3 base e. And then we have what? The e's matching up here. they cancel out because we're using this rule right here. So finally, the answer works out to be just 3. Whew. That's a long one, right? That problem is actually pretty hard, but it's doable. We just work with the exponent by itself, figure all that out, plug the exponent back in, and the rest is pretty simple.